I'll go ahead and start Management Studio. I pinned it to the taskbar here, so I can just select it there. Or I could go to the Windows Start menu and start it there. All right, so there's the main window. I'm going to explicitly connect to the local default instance. I could use the machine name as was originally shown there, but I'll connect to local. And there's the connection. Now, to set the server properties, I right-click on the connection and select Properties, and that opens up this Server Properties dialog box. So the dialog box has 8 pages of configuration settings. And then it also contains information about the current connection. So I connected to the local default instance. There's the actual full name of the connection, the name of the machine, and Don Kiley. And I can also view the connection properties if I want to. Notice that all of these are disabled, so they're read-only. But if I want to see how this connection is defined, as well as information about the version of SQL Server, the edition and the version, as well as other information, I can see all of that here. Okay. And then it also shows me any actions that are in progress right there. It's just sitting waiting for me to do something, so it just says ready. Now the dialog box includes a couple buttons at the top here for getting help, as well as scripting any changes that I make. So if I select the down arrow there, I have different options to script the action to a new query window, to a file, to the clipboard, or to a SQL agent job. So if I want to run this job as a repeating action that I want to do, I can schedule that with SQL agent. So the way this works is that if I were to make any changes to any of the settings on the various pages, then I could get the script for specifically that change. So for example, if I go to the database settings page, I'll talk more about this page shortly, but I change the default index fill factor to say 10, what I can do is come up to the script page here, or the script button, and in this case script the action to a new query editor. So I'll cancel out of the dialog box because I want to show this. So this shows you the transact SQL code that you would need to execute to make that change. And so it includes 3 calls to the system stored procedure sp_configure, which is where a lot of these kind of configuration settings occur. So this is the code that the dialog box is actually going to execute to make that change. And so I first need to show advanced options. That's essentially allowing changes to various advanced options. And then it's going to set the fill factor to the 10 that I selected, and notice that that's a percentage. And then it turns off the show advanced options. It sets it to 0 after it turned it on with 1. So this is a great way to see how Management Studio manipulates the server using transact SQL code, as well as the system stored procedures behind the pretty graphical user interface, or the GUI of Management Studio. Because all of the actions that you take with the GUI of Management Studio are in the end executing transact SQL code behind the scenes, and very often calling system stored procedures to do the work. Okay, so I'll shut down that window and I'll go back into that server properties dialog box. What I'm going to do now is I'm going to explore some of the most important and interesting information that you can view and the options that you can set using the server properties dialog box. But I do want to emphasize that anything and everything that you can do in the GUI tools in SQL Server, you can do in Transact SQL, which is, again, the primary programming language of SQL Server. And it often uses Server Management Objects, or sometimes abbreviated SMO, which is a programming object model for SQL Server. The GUI tools simply write and run the underlying code for you. So if you prefer typing out commands or want to build your own SQL Server tools, you can do that by using the same infrastructure that Microsoft used to build Management Studio and various other tools. Okay, so let's talk first about this general page. This doesn't have any settings that you can change. You can see that they're all disabled. They're kind of in a light gray. Instead, it displays a lot of information about the server and its environment. Of most interest here are the product, in this case, the 64-bit version of Microsoft SQL Server. I installed the Developer Edition, as well as the version number. So this is a long drawn-out version number for SQL Server 2016. Microsoft started out and at various times used a numeric number for the version, but since went to SQL Server 2016, a year-based numbering system. It also has information about the version of Windows that I'm running on. Microsoft Windows NT 6.3 build 15063 is Microsoft internal build speak for Windows 10. That's what I'm running this instance of SQL Server on. Now, the actual information that you're seeing here is probably going to vary a little bit from what you're likely to see on your instance of SQL Server on your version of Windows, because you're probably using a different edition, different version, and so forth. But the point here is that this is where you can get a lot of information about the environment. So note also the warning at the bottom of the page here. Microsoft Product Support Services has probably spent a lot of time helping people undo the work of power users who go in and tweak settings without knowing their full effect. So I think this is probably a CYA thing for Microsoft, emphasizing that changes to server properties and settings may affect the performance, security, and availability of the SQL Server instance. Before making any such changes, consult the product documentation. So that might sound a little bit scary, but if you kind of have a clue of what you're doing, you need to come in here and make changes. You know, I come in here and make changes all the time, including on production servers. So I probably am a little bit of risk taker in that, but this is where you go to make a lot of changes that you need to make at times. Okay, so let's go on to the memory options here. So this page provides a few options for how SQL Server, controlling how SQL Server uses and manages memory. Like most server settings, the default settings are probably going to be fine for most servers that aren't under extreme load. But if you have a server, there are problems. If you do some debugging and evaluation, you may need to tweak these memory settings. Now, the first checkbox that may appear, it doesn't here, which explains the kind of large empty space right there. This checkbox determines whether SQL Server is going to use the Address Windowing Extensions, or AWE, in 32-bit versions of Microsoft Windows to support up to 64 gigabytes of physical memory. Now, if you have this option, it means that you're running a 32-bit version of SQL Server. In that case, it also is going to require configuring settings in Windows as well. But the nice thing is that it takes advantage of huge amounts of memory for your database server. And so, because I'm running a 64-bit version of SQL Server on a 64-bit version of Windows, it doesn't appear here because it doesn't apply. So just be aware that you may have an additional option right there. All right, then the minimum and maximum settings here. These control how much memory SQL Server uses on this particular machine. Now, it's set to 0, and it's set to this amount here, which is basically the largest amount possible of memory. And the only time that you should consider changing the defaults is when the machine, this machine where this instance of SQL Server is running, is going to have other server applications on it, such as Microsoft Exchange or a web application. In that case, where you have another set of server software running, SQL Server can't be allowed to grab every byte of memory for its own use. On the other hand, if other server applications request memory only as they need it, you don't need to worry about changing this setting. SQL Server will release memory to those applications as necessary. Okay, and so again, keep in mind that this number right there doesn't relate to the amount of memory in the machine. It's simply a maximum setting and essentially means to use all available memory. Okay, then the other memory options down here are for index creation and queries, and they control how much memory is allocated for those operations. This can affect performance, and SQL Server is optimized to perform them as efficiently as possible. So it's going to be a very rare case where you'll want to fiddle with those particular settings. But if you monitor the performance of a live server and see excessive memory operations, you might consider tweaking those values. All right, and then this is the first page where these configured values and running values options appear. Some changes that you can make within the Server Properties dialog box require stopping and restarting the SQL Server service for the change to take effect. So you can select running values to see the value for each option and whether it reflects the new value. If it doesn't, go into SQL Server Configuration Manager, stop and restart SQL Server in order to make the changes take effect. Okay, next up is the Server Processors page. SQL Server supports multiple processors if they're available on the server. So the Processors page will show all of the processors that are available. In this particular case, I have a single CPU, but if, for example, I had a quad processor machine, then all 4 of the processors would appear there. And they allow me to set various settings. And in fact, if I had multiple processors, I could select which processors to use for this instance of SQL Server. And then I can select various other settings, including the processor affinity and the I/O affinity, in order to dedicate one or more processors to SQL Server, and which can reduce some of the overhead of moving threads between the processors. And that change can help the database server's performance, but may hinder Windows performance. Okay, so for the most part, you're going to want to only tweak these settings if you're resolving a specific issue. Because changing processor options reduces SQL Server's ability to manage its own resources. So you should consider making changes on this page only when you have a situation that SQL Server doesn't seem to be handling appropriately. And so you want to debug the situation and see that there's some sort of situation where SQL Server is just not making the right decisions. Okay, the next up are the security options. Security is a critical feature in SQL Server, and this page in Server Properties lets you configure a few settings. Probably the most important setting on this page is the server authentication mode right there. And the options are, just like in installation, are either Windows Authentication mode, which within the installation is the default, or the mixed mode here of SQL Server and Windows Authentication. Now this is set here because I explicitly changed that from the default during installation of this instance of SQL Server. If I didn't need to use SQL Server Authentication, then I should go to Windows Authentication mode because that's going to be more secure. But the scenario that I was looking at here is that I have applications that need to connect to the SQL Server instance using SQL Server Authentication, not just Windows Authentication. If I didn't have that situation, again, I would want to use Windows Authentication. Okay, then I have login auditing options here. These control which authentication operations are logged in the Windows event logs. The default here is failed logins only, which is a great tool to alert you to some kinds of attacks, such as a dictionary attack on usernames and passwords. But there are other options which log additional information, and the more information that you log, the better chance you have of troubleshooting. but the greater effect on performance because it's logging more information, as well as an impact on disk space because it's saving to disk, to a SQL Server database, additional information. Okay, the next up, if you need to, you can enable a proxy account for use when calling the XP command shell extended sort procedure, which runs code in a Windows command shell. Code that runs in the command shell has the permissions of the specified user that you define here, if you define a proxy account. Okay, then you have some additional options here, and in particular, the C2 audit tracing configures the server to record attempts to access transact SQL statements and database objects. And this saves a huge amount of information, so you're going to need to monitor the disk files to make sure that you don't run out of disk space, which can cause SQL Server to shut itself down to prevent attacks. But it records a lot of auditing information, which is required in some environments. And then this cross-database ownership changing option can enable ownership chaining across SQL Server instances. This is potentially a security hole, so you should have a good reason to enable this option. Some very advanced options here. Okay, the next up is a dialog box that lets you configure client connections. So what this page is doing is it lets you control how applications connect to the server and set the default properties of connections from client applications, including the tools in SQL Server, like Management Studio. So you can set the maximum number of concurrent connections that service, this is limiting the number of connections that service those connections. But if you set this too low, it can leave clients waiting for a connection, which affects the performance of your applications. Then you have this option to use the query governor to prevent long-running queries. The idea here is that sometimes rogue code can get into an infinite loop and continue to hog resources until they're all used up and SQL Server, or maybe Windows, dies. So the query governor option can limit the execution time of any query. So you can specify a time in seconds that SQL Server will allow a query to run before shutting it down and rolling back whatever transaction that it's involved in. So the default is 300 seconds. But I can click on that checkbox and set it to whatever makes sense. I'm going to disable that. So you want to be careful not to set that time too low, because it can cause client applications to receive error messages when a query can't run to completion. And hopefully all of your applications handle that exception. Okay, then this list in the middle of the page lets you set the default connection options. If a client connects with a connection string that doesn't specify any of the values that you select here, the value will be set to what you specify. So most of the defaults are acceptable for most servers, and all are fairly advanced options that can affect how you write code that accesses the server. But again, if you're facing a problem, this can be a solution to various kinds of problems. Then we have the section here called Remote Server Connections. This lets you specify whether this instance of SQL Server allows remote connections. This determines whether the instance allows client connections from any machine other than the one on which this instance is running. Now, disallowing remote connections is a great security option in situations where the databases support only local applications. And an example of that is where you have a web server running on the same machine as this instance of SQL Server. But if client applications on other machines have to connect to the server, then you'll need to enable them here, and that's the default. And in fact, it's been a default since SQL Server 2008. And then you can also specify the query timeout for remote connections. And notice that this default is 600 seconds, a little bit longer than queries on local, or queries coming in from the local instance. Okay, the next up is database settings. This lets you set properties for both existing and new databases. The default index fill factor here specifies the amount of empty space that SQL Server leaves in new and rebuilt indexes. In general, this amount that's specified as a percentage should be lower for databases in which the data doesn't change much, and higher when data is constantly added and deleted. You want extra space within the index so that SQL Server doesn't need to rebuild the index as often. So overall, this setting allows the index to accommodate changed data without requiring SQL Server to move entries around. Generally, you'll want to leave this at the default 0 because that lets SQL Server optimize the fill factor for you. And in by far and away most cases, that's going to be just fine. If you start fiddling with this, taking control of it, you could face issues. You have to stay on top of it. All right, this backup and restore area lets you configure backup options. The recovery interval is the time that SQL Server takes to recover a database when it starts up. During recovery, SQL Server rolls back transactions that didn't commit and rolls forward transactions that did commit, but the changes were not yet written to disk when SQL Server stopped. SQL Server is a very robust system in terms of recovering from any problems that cause Windows to shut down or the service to shut down or whatever. So this default of 0 for the recovery interval means that it's set automatically. And whether all of these options are enabled throughout here depends upon the recovery model that's used by this SQL Server instance. And then here's where you can change the default locations for data. When I installed this instance of SQL Server, I accepted the default locations for these. But I could have changed these to a different location. Had I made that change, those would be reflected here. But I can still make these changes. It's important to understand, though, that any changes to these settings here won't have any effect on existing databases. So if I change the location of data files to a different volume here, then it's not going to move any existing databases, but any new databases that I create will go to that new location. All right, the next page I have is the Advanced Settings page. This lists a variety of pretty rarely used but important settings. You should probably review all these settings, but not change most of the settings. So most of these really are advanced, but there are a few that you might consider changing. One of them is this allow triggers to fire others. A database trigger is code that runs when data changes in a table. Although it's sometimes useful, by allowing a trigger to fire another trigger, you can easily get into an infinite loop that can hog processing time. Because maybe you have a trigger when data in the customer table changes. In that trigger, it changes data in another table that itself has a trigger that makes changes to the customer table. And so there's changes to the customer table, the original trigger fires, which causes data in the other table, and that's how you can get into an infinite loop. So you need to be careful with triggers, and this is enabled by default, but you might want to consider changing this to false so that you entirely prevent that kind of situation. But there are times where you need to enable it because you have code and triggers and so forth that need to perform changes in multiple tables. Okay, then we have the default full text language and the default language settings here. These specify the language that's used in SQL Server by default and the syntactic characteristics of searches in data. The default options here should properly reflect the language that you installed this instance of SQL Server under. I'm in the United States, I speak English, and so they're set to United States English by default. Okay, and then the last setting that I want to talk about is the 2-digit year cutoff. This is a throwback to the Y2K problems of nearing 2 decades ago and Good riddance. Okay, so this setting was really more of a concern during the Y2K scare at the end of the last millennium, but is still applicable. So if dates with only 2-digit years are stored in the server, by default, if the value is less than 49, the year is assumed to be between 2000 and 2049. If it's greater than 49, it's assumed to be in the second half of the 20th century, from 1950 to 1999. Okay, so really, if you're still dealing with 2-digit years, you're messing up. Just work with 4-digit years. There's going to be a Y10K problem in about 8,000 years from now, but unlike the Y2K problem, I kind of suspect we're not going to be using SQL Server, we're not going to be using Windows 8,000 years from now. So you're probably okay in just using 4-digit years. If you're really concerned about your applications being in effect and usable 8,000 years from now, well, use 5-digit years. Okay, and then the last page is permissions. And this is where you get a list of the principals and explicitly granted permissions that each principal has at the server level. Now, I'm not getting into security here, but briefly, a principal is a user or a code process that you can grant permissions to access various database and server objects. And that allows you to define and control access to the server to protect the data that's stored there. Changing a permission in here for a principal affects the access that that principal has to the server. In other words, it changes what the principal can do and see in this instance of SQL Server. All right, and that's all I'm going to say about permissions at this point.